Hi friends, welcome to my YouTube channel. Hope you all are doing good. In today's video, we are going to discuss about how to develop a stiffness matrix for a beam element. If you like this video, please do subscribe to my channel. Your subscription would greatly help me. And coming to this topic, without any further delay, in the analysis of a continuous beam, normally axial deformations are considerably negligible. We generally consider that axial deformations, that is in this direction, are considerably negligible. So we will not be considering this axial deformations. We'll just be considering the vertical reactions along with the moments in both the support. Okay, this is a beam element we have considered, which is having a constant modulus of rigidity, that is E, and I is constant for a length of L. Okay, next, coming to the three combinations we are considering, we have reactions and moments. So firstly, we have reaction and reaction, that is 1-3 or 3-1. Whenever we are considering both reactions, we'll have this formula, this 12EI by L cube. But we are considering reaction and moment, that is 1-4 or 3-2. First one would be reaction and second one would be moment. In that case, the formula would be 6EI by L square. Moment and moment, if that is 2-4 or 4-2, that is 4EI by L or 2EI by L. See, in all these cases we have single formulas, but here we have two formulae. So they are, where the application of moment is there, that is the direct movement, would be 4EI by L. But whenever we are talking about the carryover movement, see, if we are considering support 1, okay, here the movement would be direct. But whenever we are talking about support 2, here because of this movement, whatever the reaction that is taking place, so because of that, whatever we are having this diagram, see, coming to this diagram, we will be having something like this. So this is the carryover movement, that is because of this movement, this is the movement that is carrying over, okay, at this support. Okay, for this we will be taking 4EI by L, but if we are considering this movement, that is because of this one, that is the carryover movement, we'll take 2EI by L. I'll be explaining you in further cases. Okay, first of all, to get the stiffness matrix, we'll be applying some unit displacements at 4 coordinates. That is, first coordinate would be the vertical reaction at support A or the support 1. Okay, this is support 2. 1 would be the vertical reaction at support 1 and the movement at support 2. Sorry, support 1, and 3 would be the vertical reaction at support 2 and 4 would be the movement at support 2. So whenever we are applying the unit displacement at coordinate 1, that is, we are just applying a vertical reaction or unit vertical reaction, that is of 1 unit. So because of this reaction, what would be happening? See, whenever we are talking about this beam, this would be applying, it is in this direction, right? So the bending would be lifted. See, initially the beam is like this, but because of this application of this unit load, this would be going to this level and this would be in this direction, the opposite reaction. Okay, so whenever we are talking about this support, as this is in the upward direction, movement would be in this direction, right? To lift it in this direction, the movement should be from downward to the upward direction, in the anti-clockwise direction. Here also it should be in the anti-clockwise direction to keep it in this direction, right? So whenever we are talking about K11, 11 is nothing but the vertical reaction, that is both are in same direction. See, initially we just have to assume one direction as positive and other as negative. So we are considering as the anti-clockwise to be positive and the clockwise to be negative. Okay, this is your assumption. First of all, considering K11, see, we know 1 is in upward direction. Initially the diagram was like this, right? So these were the directions we have considered. So whatever the directions that are in the opposite directions of that we are considered would be negative. Okay, see, K11 in the upward direction, here also 1 is upward direction, so would be positive. And I told you, whenever it is reaction and reaction, it would be 12EI by L cube. So K11 would be 12EI by L cube. Coming to K21, 21 is nothing but the movement at support 1, that is 2-1. What is first one? First one is movement, second one is the reaction. Whenever it is movement and reaction, we are having 6EI by L square. Okay, and as it is also in the same direction, I told you, because of this the movement should be in anti-clockwise direction. Even the 2 is in anti-clockwise direction, it would be positive. Coming to K31, again it is a reaction, 1 is also a reaction. So when both are reactions, it will be 12EI by L cube. But we considered the third one to be upward. Okay, initially we considered third one to be upward, but here we can see it is in downward direction. So it would be negative in nature. Coming to the K41, we have one as the movement and other it is a reaction. When one is a movement and other is a reaction, that is 6AI by L square. Okay, and coming to the direction, see, to develop this reaction in the downward direction, it has to be an anti-clockwise reaction. Okay, if it is in a clockwise direction, it will be lifting, but we want it to be in the downward direction, so it would be simply anti-clockwise in nature. That is in same direction of 4. Again it would be positive. Okay, now we will be applying the unit displacement at coordinate 2. At coordinate 2, that is nothing but we are applying a unit movement. A unit movement, that is K12. See, whenever I am telling K12, 2, 2, 3 to 4, 2, that is 2 is nothing but the displacement where we have applied. Okay, because of this deflections, that is deformations or displacements we are applying, whatever the displacement that are taking place at 1, 2, 3 and 4, we are evaluating. Okay, second one would be the point at which the displacement is applied. First one would be the displacement at which we are evaluating. Okay, coming to this, we are applying a unit displacement in same as the direction. See, I told you 2 is in anti-clockwise direction. Okay, so if it is in this direction, it will be lifting it upward, right? So upward reaction, and if it is lifting it upward, something should be there to support it downward, right? So it will be downward in nature. That is, again, it should be anti-clockwise in nature. But initially we have considered these directions, right? So let's see, if it is in these directions, like the initial one considered, they would be positive. If they are in the opposite direction, it would be negative. So K12, that is one movement and one reaction, 6EI by L square. 3-2 is also one movement and one reaction, as it is in negative direction. See, we are considering it to be, this is upward direction, it is in downward direction. As it is in the opposite direction, see, 3 is nothing but the vertical reaction, right? This is the vertical reaction, but here we can see it is in downward direction, so we are taking it as negative 1. K1 is positive, as it is upward, whatever we consider is also upward direction, so negative, positive. But the third one is downward in nature, so it would be negative. Okay, we considered upward as positive. These are the initial one we have considered to be positive. See, initially we have considered this, right? Whatever the directions we have considered, we are taking this as positive. Okay, coming to K12 and 3-2, we are done. Coming to 2-2, that is both are movements. Whenever both are movements, see, remember, whenever 2 and 2, that is whenever these two are same, we are applying at that point and we are seeing at that point. Okay, that is, it is 4EI by L. And 4-2, both are movements, but this is a different node. That is, we are seeing the carryover of that. How this movement is carried over to that point, that is 2EI by L. Okay, whenever both are movements, we will take 4EI by L and 2EI by L. Whenever, that is, whenever they are same, it is 4EI by L. Whenever they are different, it is 2EI by L. Okay, and coming to the direction, that is negative or positive. See, even this is in anti-clockwise direction, this is anti-clockwise direction, this is same as that of the initial condition, right? So it is positive in nature. Coming to this, due to displacement at coordinate 3. At coordinate 3 is nothing but the vertical reaction we have applied. If it is vertical, means it is vertically upward, so it should be clockwise, and there should be some resisting force in the opposite direction, and they should be anti-clockwise, clockwise. So K13, see, 3 is nothing but the reaction, this is the initial condition we have taken, right? So 1 3, that is both are reactions. If both are reactions, simply keep 2LEI by L cube, and 1 3 it is clockwise, but here we have considered the anti-clockwise one, that is the upward one. Okay, here it is downward, so it is negative. 2 3, 2 and 3, movement and reaction. Movement is in opposite direction, we have considered it to be anti-clockwise, but here it is clockwise, so it is negative. Formula is 6EI by L square. 3 3, there is both are reactions and both are in same direction. See, this is also upward and this is also upward, so it would be 2LEI by L cube. 4 3, 4 is nothing but the movement is in anti-clockwise direction, but whatever we got here is clockwise, so it is opposite, we are taking negative 1. Formula is 6EI by L square. Coming to unit displacement at coordinate 4, that is 4 is nothing but the movement, the anti-clockwise movement, that is it will be going downward. See, if it is in downward direction, something should be there in the opposite direction, okay, that is upward one. So if it is upward, it will be anti-clockwise. K14, 1 4 is nothing but one reaction and one movement, that is 6EI by L square, and 3 4 is also reaction and movement, right, that is 6EI by L square, and 3 is in upward direction we have considered, but here it is in the downward direction, so it would be negative of that. Okay, K24, 2 4 is nothing but movement and movement. If both are moments, we have to take the carry over and that side. So 4 4 both are same, 4EI by L, one is different, 2EI by L. So both are movements, basically they are both movements, but at one node we are applying the force and at the other node we are evaluating the displacement cost. So we'll just be writing the stiffness matrix. We'll be taking EI by L cube common. Okay, EI by L cube, that is 12EI by L cube we have here, right? So we'll be taking EI by L cube common. So we'll just be writing this, that is nothing but K11, 12, K13, K14. Okay, here it is again K21, K31, K41. Okay, this is the matrix, stiffness matrix for a beam element. But here we are not considered the axial deformations. We say that the axial deformations are almost negligible, but if we had to consider that, what would be the stiffness matrix? If the axial deformations of the beam are to be considered, it may be observed that two axial forces do not affect the shear force of bending moment and vice versa. That is, see, this is the diagram we have considered. We have taken again the positive ones as upward and the anti-clockwise movements, but the axial deformations in the right hand side direction. So for the above matrix, this would be the equation. Okay, this would be the stiffness matrix equation. That is it for this video, guys. If you like this video, please do like, share and comment to the channel, and don't forget to subscribe to my channel. Your subscription would greatly help me. I appreciate you watching this video. Thank you.